Okay, gang. I'm not entirely sure why I lost the whole video here. But I lost the whole video of me doing a bunch of work. So I'm gonna go back and review how I did it, but I've done it already once on video and it's taken about 20 minutes. So hopefully this thing won't just spontaneously quit again. Okay, so if I'm doing mole conversions of a single thing, if they're asking me how many particles are in 3.5 moles of magnesium, then all I need is a dimensional analysis cross. I have 3.5 moles of magnesium, 1 mole of magnesium, and I'm going to particles, 6.02 times 10 to the 23rd particles. If I multiply those two things together, I get 2.107 times 10 to the 24th particles of magnesium. You see how I set that up? You have to know the relationship. Remember that the units of my answer go into the top right, and remember the diagonal rule. Diagonal rule says that whatever the units here, moles of magnesium have to be the units here. Moles of magnesium. On number 2, I have to do two-dimensional analysis cross because I'm going from molecules of water to grams of water, and there's no way to go through that without moles. I have a mole relationship. I know that 1 mole equals 6.02 times 10 to the 23rd molecules, and I have a grams. I know that 18 grams of water are 1 mole, but I don't have a grams to mole or a grams to molecules. So we start here. We put our known 3.14 times 10 to the 23rd molecules of water. Right here, molecules of water, 6.02 times 10 to the 23rd, and 1 mole of water. We're going to moles, remember? Units of my answer. Once I get my answer in moles, 0.5647, I'm plugging that into another dimensional analysis where I'm going from moles to grams. Moles of H2O, 1 mole of H2O, 18 grams of H2O. Multiply that out, I get 10.166 grams of H2O. Okay, now then. Okay, so empirical formula. Empirical formula, you're looking for something that you can't factor out of the subscripts. You're looking for a greatest common factor. So like right here, C6H12O6, 6 is the greatest common factor. I can factor that out of all 3 of those. So that is not an empirical formula. And right here, I could take 4 or 2. 2 would factor through into 8 and to 18. It would be 4 and 9. So that is not an empirical formula. Here, again, I can factor out a 2. That's usually what I use to check. I go, can I factor a 2 out? Because it's the quick check. Now, right here, I can't factor a 2 out because 2 won't go into 11 evenly. And there's no greatest common factor, especially with 12 and 11, so that is my empirical formula. By the way, anything that has 1 of something, like if it has 1 carbon in it, that is your empirical formula because you can't factor a 1 out of anything, right? Just a side note, quick side note. So now knowing that, we go down to number 4, C8H10N4O2, and I find the greatest common factor is 2, and I factor a 2 out. So that becomes C4H5N2O. Factor the 2 out of all of this. Oh no. We avoided it so well the first go round. And now, come on. God. Just turn on. Oh.
Is everything okay?
No, the stupid lights won't.
Hey, you guys come out here. There you go.
And it's driving me batty because now I'm wasting time. What?